So hi everyone, welcome to the session. So right now what we have is a workshop for our LLM Zoom camp. And you can find more materials about this workshop. And this is where we will also have homework for this workshop. If you go to the course repo, if you're not taking the course and you just discovered this stream, I am going to put the links right now in live chat and then later in the video description. So you will find it here. So here you go to cohorts. Right now it's 2025 cohort. We have workshops and DLT workshop is here. So here, everything that is related to this workshop today is going to be here. We will add homework here. The notebook that we are going to use is this one, Collab notebook. It's already linked because I just accepted the pull request. So this is what we are going to use to follow along the workshop. So you can follow along right now. And if you're watching this in the recording, just follow along the video. And as always, you can ask questions in Slack. Okay, that's all I wanted to say. Maybe just as a side note, I want to thank DLT for their ongoing support because we have worked with DLT for so long. It's already, I don't know, third year that we work together, so it's really cool. Thanks for doing what you do, and I'm really happy about this collaboration. And right now, I'm stopping sharing my screen, and now Hiba, the floor is yours. Please start.
Thank you. So,
and I just want to say maybe to finish, sorry, I keep saying the floor is yours, but I keep interrupting you. So I want to end the poll, and 70% of people said yes, they have heard about DLT. So really good.
Cool. Okay, so I'm just gonna share my screen. Just let me know if there are any issues there. Okay.
I can see a screen.
Cool. All right, are we in slideshow mode? Is it good?
Yeah.
Okay, perfect. So welcome once again to the Cognney and DLT Zoom camp. So before we start, a little bit about me is I am an AI engineer at DLT Hub. Previously, I like to say that I do data and I do AI. I have worked in data science and machine learning roles within startups and also in academia. Right now, I build data pipelines, AI pipelines, RAG systems, dashboarding, analytics. I do that stuff, and I think it's quite fun. And my LinkedIn is linked right here. If any of you want to connect, we can do so. But yeah, you will also learn a little bit more about my work and get an idea of how we use AI inside DLT Hub in the second demo. So yeah, but we have a while till we get to that. So let's just start with the topics. So here is what we'll cover. What we'll be doing is first we'll be going over some basic concepts before we jump into any code. It's really nice that 70% of you already know what DLT is, but we'll still go over like a tiny bit of an introduction. Then there will be a refresher on RAG systems. I assume that if people have joined in here, some of you may already have worked with RAG systems or not, but for everyone, it will either be a refresher or an introduction. So yeah, then we will go into what is Cognee, which is the other tool that we'll be using, and then another very core concept of Cognee that we will be exploring, which is node sets. So after we've gone through a bit of these, a bit of this theory, we will then go into an application of it, which is the taxi data set. And then we will look into, again, another topic, which I'll talk more about when we get to it. And we will then conclude with some takeaways. Just FYI, if you guys want to, code together for the first example, I would suggest that you can just go and run the entire collab right now without really going through it, because it takes time to build a knowledge graph. So if you would like to, then just start running it right now. So by the time we actually get to it, you already have your own little knowledge graph built. Yeah, so if anyone wants to do that, please do so. So basic concept number one, what is DLT or data load tool? So this is the main idea of DLT. We take data from one place and then move it somewhere else, or in better words, from source to destination. We believe that every single data job eventually becomes a data engineering job when you go through like any ELT or ETL process, even as a data scientist, like even in my previous roles where I didn't really have anything to do with data engineering, there were always tasks around it where you had to manage where your data was being extracted from, or if you have to like throw it somewhere else. And DLT is super helpful with that. So it is an open source Python library where you can build your data pipelines using just Python. It helps you with the ETL or ELT process. So you extract data from APIs or any source that you have, transform or normalize it, and then load it to a destination, whatever database that you would like. And then there are other little caveats of data engineering, like you have to manage schemas, states, incremental loading. So that is all something that DLT helps automate pretty quickly. So yeah, and when you run your pipeline.run command, which is just, after a few lines of writing down what your source is and then what your destination is, this is what DLT does. It extracts the data from a source, it normalizes it, and then it loads it to whatever destination that you have declared. And once again, since we're talking about source to destination, there are some supported sources inside DLT, like the ones that you can see here, and then some supported destinations here. So, you don't have to write like extra code to be able to connect to these things. But always, if you have a source that's not mentioned here, you can always do that yourself. And it's pretty easy to do that yourself. The same thing with destination. If you have one of these destinations that you're working with, that's amazing. And if not, then you can always write your own custom destination as well. So yeah, that's a bit on DLT. How we'll be using DLT is just for the data ingestion process, ingesting a data set into a local DuckDB destination, which is what we'll do in the Colab demo with the taxi data set. And then for the second one, we will be ingesting data to a local file system. So yeah, I think this entire session will be more on you understanding something than putting something to production, even though we have like a bit of that as well. But you can see in both of these, we have ingesting into a local DuckDB destination, and the second one is ingesting to a local file system destination. But changing that to production literally requires a variable name change and nothing more. Right, now we get to the other concept here before we jump into Cognee, a refresher on RAG systems. So if you can see this, we have, for example, we talk to ChatGPT, all of us talk to ChatGPT or any other LLM that we're used to, but if we want it to have some customized or context relevant results, then we can build RAG systems. And for example, we have docs here. These docs can be anything. For example, you want to communicate with a book, right? So you load that book or those books as docs. You create meaningful chunks out of them because you cannot load an entire book to a single prompt, right? So you chunk it in a way that it becomes small little meaningful pieces that your system can then look at. Then you have to add some form of embedding. There are a lot of open source embeddings available for text, for code, for different languages. Yeah, that is just turning your text into the form of vectors that your system can understand and do some calculations on. So yeah, you have your sources, you chunk them, and then you add your embeddings on top of it. And then when you want to ask a certain question, so that's where we start in here, the user query. In order for your query to be able to talk to your sources, they have to be in the same format, right? And in the same format, they both have to be the same or somewhat the same embeddings, so that there can be some sort of calculation done on them, which is, I think the easiest one is cosine similarity. In some places, like a very, very simple systems, it could also be like Euclidean distance, Manhattan distance. Yeah, there are many, but the idea here is that your user query gets translated to a form where it can actually talk to your sources, so that when you take when you apply a mathematical function onto it, then you can get like the most similar results out of your sources. So then you get some relevant docs out of that operation. And once you have those relevant docs, like for example, what you asked is in 2 chapters of a book, those 2 chapters will be returned here. And then your user query goes to, for example, Perplexity Sonar or GPT with this context. So you asked, okay, what is in these 2 chapters? Those 2 chapters are retrieved, and then that goes as a full prompt to your LLM, which then you make the call to the LLM and you get a response. So yeah, that is just a small refresher, a reminder of what a RAG is, or introduction to what RAG is, where again, it's just context relevant querying into your custom information or sources. Okay, now we can move on to what is Cognee. So the main idea behind Cognee is, again, right, you have your custom data sources, and then that gets ingested or integrated to some sort of a knowledge base, right? In the previous example, it would be this vector database here that would store all of the vectors that are in your docs, right? So this database could be LaunchDB, it could be Qdrant, VV8, it could be anything. But here we want to make a knowledge graph, or yeah, a graph RAG. So your data sources get transformed into a graph RAG, and then there's very efficient retrieval that can give you improved LLM outputs, which we will look into how that happens. So what is Cognee? Cognee turns your data into queryable memory and knowledge graph. And this is essentially like the difference between like a normal RAG system and Cognee is that Cognee actually gives you a knowledge graph instead of just a vector database. And once we look at more examples of what this can visually look like, it'll make more sense. So Cognee lets you add structured or unstructured data because it also has DLT integration into it. So DLT also can understand structured or unstructured data, so does Cognee. And then after you add your data, you can automatically build a knowledge graph from it, and you can ask natural language questions and get answers that are rich in context, just as we try to do in any RAG systems. We want our answers to be context aware, not just general search from GPT. So this is an example of a knowledge graph. So we have nodes, right? It is an actual graph where you have different nodes and you have relationships between those nodes that Cognee reads and creates, right? So perhaps someone has fed into this any piece of text, maybe a text file even, and it could understand that there are 3 entities here. There's Alice, there's a book, and there's Park. There's something called a reading event, and Alice is the one reading it. What is the reading event on? There's some book being read. It is at the park. And then there's another independent event called purchase event. And the purchase has been made by Alice, and she has purchased the book, right? So this knowledge graph instantly becomes more rich in context, where it didn't just break down your original sources into vectors, which of course it does, that's part of the process, but it also then builds these relationships, these semantic relationships between your different data points. And just like that, it can become better and more rich when you retrieve information from it. So
I see that there's a question, and so the way I interpret the question is, let's say we have a book, that the example you showed in the previous slide of Iraq. Can we turn the information from the book into a vector automatically? Let's say, I don't know, we read Game of Thrones, and in Game of Thrones you have like multiple houses, like there are some people in the houses, there are different events where these people participate. Can we automatically get such a graph or any knowledge graph from an unstructured text like a book?
Yeah. So that is where Cognney comes in, and it automates that process. And we will see that more in when we come to the code part of it, or the first demo that we'll do. It'll instantly become easier to understand how Cognney adds information. I just wanted to give a refresher here before we get to that, or introduction here before we get to that.
Thank you.
Thank you. Okay, so we now know what a knowledge graph is and what DLT does. DLT is for data ingestion. Then we know what a RAG is. We get context-aware results from it. And then we know Cognney, that makes your RAG systems a bit more enriched by adding these relationships and these semantic meanings within the data. So then, just like we had a pipeline.run function, if any of you have used DLT, you know that the last step to actually running the pipeline is pipeline.run. And I would say that for Cognney, that command would be cognee.cognify, which I think is quite a cool word to use to actually say that I'm about to build something. So when you run cognee.cognify, what happens first is whatever text documents or books or JSON objects that you've added, they get parsed. Then the knowledge graph is built. Then it's enriched the way we talked about. It builds these relationships. It adds semantic information, and then it gets saved to Cognee memory. And then if you want it to exist somewhere in the cloud as well, you can do that, which we will also look into. So yeah. So before, I think this is the last thing that we'll do before we jump into the demo. What's the time? Yeah. Challenges of RAG systems. So first, I mean, there are many challenges of RAG systems, but I will pick my, I wouldn't say favorites, but I would say the ones that are the biggest headaches for me. So the retrieval, quality, and relevance. So I'll give you an example here. When we were building one RAG system for DLT, right? The goal of that was to be able to look up information in a lot of different sources. What were the sources? There were some books on marketing. There were some docs from DLT, from DBT, and we wanted to look through all of them and then maybe create some meaningful blog out of it, right? So what we would do is, okay, we'd say, please write a 600-word technical blog on transformations with DLT and DBT. And then, as a RAG does, it transfers this particular prompt to a vector. Then there's a vector search inside of your vector database, and then it gets the relevant information out of it. Now, there are a couple of questions here. what it got, what it retrieved, was it actually relevant? And that's one part of it. The other part of it is that enough information to actually inform what the blog needs? So here, this is the first challenge. The graph retrieval may be irrelevant or incomplete. And Cognee's solution to that is it uses that semantic graph to identify and connect relevant facts. So it's not just a vector search, it's also a semantically enriched graph search, which becomes better. And we'll look at one example of how.
A quick question. Would Cognee help in cases like legal documents where context can be scattered on different pages? I think the answer is yes, right?
Yes. Yes, I would imagine you have like a bunch of different legal documents. It will take out some nodes that are relevant to it, make some concepts out of it, and then those concepts will be connected to other nodes that will have specific information that you're looking for. So it will, I think the information would not get lost if it's looking up that information, since it will be connecting it through concepts, not just through a cosine similarity.
Mm. And sorry, since I interrupted you already, what you mentioned about getting some marketing posts and then some documentation from DLT and DBT, this sounds like an excellent project idea. So if somebody is looking for inspiration for their projects, for the capstone projects, for the course, you can do something like that. I think it's an amazing idea where you want to write a blog post based on some information you have in your knowledge base. I don't remember we had such applications, such projects last year, but if you're looking for ideas, for inspiration, this could be one of them. I think this is a great idea. Thanks for sharing.
Yeah, I mean, if anyone is considering that though, I would say that the tricky part there is to actually evaluate the results of the blog, whether the blog is actually SEO optimized or if it's just a lot of GPT. Well, I can't find another word, but a lot of GPT garbage. That could also be a possibility. So yeah, that's something to look out for. Right, coming back to the challenges. So we went through the inaccuracies of retrieval. Then there's ranking and consolidation, right? So this is also kind of linked to what we talked about above with the inaccurate retrieval. When you are retrieving information, you will always be retrieving information with a certain level of accuracy, right? So for example, when you do cosine similarity, you will have something that is very high in accuracy, or in match, there's something that matches only 80%, there's something that matches only 70%. So there is ranking with when you retrieve documents inside RAG systems. So again, right, retrieval chunks are not always ranked by usefulness, which is where Cognee comes in because it is semantically enriched. And the graph structure helps prioritize the most relevant information for the query. So yeah, it's not just a kind of depending on cosine similarity scores. I think I've mentioned cosine similarity a lot of times, but I think I'll keep doing it because it's an easy example to imagine when we're talking about RAG systems or just similarity scores. Then we have, I think, a data engineer's biggest nightmare, which is pipeline scalability, and then also data ingestion, right? So when you have traditional RAG systems, scaling large data sets and really complex sources, it becomes quite resource intensive, right? Where do you store the sources? Where do you store the vectors? Is the retrieval and the incremental saving of new sources, is that basically where is that, how is that done? It could be quite complex. And Cognee's solution is pretty cool because it also integrates DLT into it. So it has LanceDB. So LanceDB is a vector database, but if anyone has worked with LanceDB, it's pretty cool because you get to do local development. And then if you want to change it to cloud, there is, I think, LaunchDB has a cloud version, but then you can also store stuff into like a GS bucket versus a local directory. So yeah, you can do local development, and then since it also integrates DLT into it, it instantly then becomes easier to add in new, more sources and enhance your knowledge graph incrementally. So yeah. Now here is an example, right? So I've gone over like my 3 biggest headaches with rack systems. This is an example that Cognee contributed to us. So we have some context here. Leo likes German cars, advanced tech and high performance sport features. And Leo is asking which exact car model should I buy? So an LLM would, again, right, since it's not context enriched, an LLM could say that Leo should buy an electric sports car such as Tesla, Roadster, or Porsche Taycan. Excuse me if I have butchered those names, but yeah, as compared to that, Cognee would be much more precise since it has different connections within the nodes, and it would be precise on which car produced between 2019, 2025 with precise kilowatt hours, with battery, where it's produced. Yeah, I think the rest of it is just this preference is based on his preferences for electric cars and emphasize on sustainability. But as you can see, like it was much more precise than what a normal LLM would give you. So that is like one example of how you could overcome those challenges. So that's 5, cool. I think this is the last thing that we're going to go through before we jump into the demo. So what are Cognee node sets? So we now know what a knowledge graph is. We will just look at one more theoretical piece, which is node sets. Node sets are basically tags that you associate to different nodes within a Cognee knowledge graph. That, yeah, it'll help you kind of look into different topics and isolate them when you're searching for it. And we will look into why this is super important, especially as your data grows and grows. It becomes super important to be able to filter out stuff based on some tags that you have put in yourself. Then there's better organization that you can put in. There's improved retrieval, which again, we will look at. And yeah, your analysis, which basically then comes from your search, will also be isolated and within that topic. And this can then be scalable, because once you have nodes that increase, you have a knowledge graph that, and since it's a graph, it can actually quite, I believe, exponentially grow. So introducing node sets can actually help you search into it. Then, yeah, this is just something to look out for in case you want to use it. Node sets are supported with Neo4j and Kuzu. We will be actually using both of them. So yeah. Finally, now we can get into the first demo. So if you were able to run the first demo here, which I hope, I don't know, maybe someone did, maybe someone didn't. But this is the crux of it, and you will be able to understand maybe perhaps a lot of things that we went through, and then also use DLT and Cognee.
I'm going to share the link one more time. You'll see this in the live chat, and also if you scroll, if you are watching this in recording, you can see it in the description.
Okay. So if someone is familiar with other ZoomGAMs, I suppose the taxi dataset should be known. But if not, that's okay too. We will go through it. So the first thing that we will do is set up the system, Cognney and Kuzu. And as we just saw that Kuzu is one of the destinations for a graph database. In my mind, I think as someone who is really used to DLT, we use DLT and DuckDB a lot. DuckDB is a really good local alternative to use. And I think Kuzu is just like that, but for graph databases instead. So, right, and installing these is just a pip install. Right. I would have loved to run this, but I think if I run it right now, then it'll take like a really, really long time to actually create the knowledge base. So I will just be going through this. You most certainly need an API key to be able to run this. It can be an open API key, a Gemini key, or whatever. But Cognee requires this for you to start. Yeah, so we did the setup and we set up the environment variables. So of course we have the API key, and then we have the database provider. It is super important whenever you set up a Cognee project to actually establish what your database provider is. Yeah, it could be Kuzu, it could be NetworkX, it could be Neo4j, whether local or on the cloud. It could be anything, but it's important to put this down here. I think the default of this is NetworkX. So if you don't say anything, it will probably just default to NetworkX. But anyway, so the data that we'll be using is the NYC taxi dataset, right? And let's just look at it. That's better. So even if you just look at one row of this, it has details of taxi trips within New York, and they are all from within, at least the first 1,000 rows here are all from within 2009 June, right? So it has passenger count, it has payment type, rating if there is, where the trip started, where it ended, the distance, pickup time, etc. Now, I thought that in order for us to kind of use Cognee here, one quite a practical example is using partitioning, right? So whenever we have just partitioning on our regular databases, it could be in BigQuery, it could be in Postgres, or whatever database you use. And if you don't know, partitioning could be just splitting up your database or a table into different parts so that you can query into it a little bit better, and then for other reasons as well. So we have time here, and since I know that these first 1,000 rows are all from June of 2009, I thought it would be interesting to partition this within 3 parts. The first 10 days of June, the second 10 days of June, and the last 10 days of June. So that is what we are going for here. So first off, we're just going to be working with the first 1,000 pages here. And we will be partitioning it once again in three different parts: the first 10 days, the second 10 days, and the last 10 days.
Just want to interrupt you quickly, sorry. So there are comments in chat that if people use OpenAI key, it works, but if they use something else like Google API key, Gemini, it does not. Do you know if we need to do any extra configuration for other LLMs to work if it's not OpenAI? Maybe we need to also say, because it needs to know which provider to use, right?
Yeah. I think the default here is OpenAPI.
Yeah.
Yeah. I think if not, then maybe we'll have to go into the Cognee Discord to figure this out. But I have experience with OpenAI, so that does.
Okay, so this example is for OpenAI key. So I see if I go to GitHub and in the setup they say, yeah, LLM API key is your OpenAI API key.
Okay.
But I'll share the documents in live chat. I think I found something.
Thank you. Yeah, but just in case, I will remove the others here so that it's easier for at least this collab to run with OpenAI. Right. Coming back. So now we know what we want to do. We want to partition our data and we will load it from that certain URL. And okay, DLT does support partitioning, but not using it in this collab because it can get a little complicated, I guess, for someone who is not used to that. So we'll just be using data frames. So we get the URL, we load it, and then we put it into these 3 bins according to the dates. Yeah. And then we run the pipeline. Again, for the 70% of you who are used to DLT would be used to this part of the pipeline, which is where you declare the pipeline with a name, a destination, a dataset name. The destination here is DuckDB. If you are running this, you will see DuckDB and a DuckDB instance showing up here in your files. Yes, I have used up my GPU for today. Yeah, and then you just do your pipeline run, which we saw in the presentation first. Pipeline run just actually goes into your resource, it extracts the data, it normalizes it, and loads it to your destination, which here would be DuckDB. And we see here that the pipeline was loaded to DuckDB, and this is also what you should be seeing here. If something goes wrong in this step, or if this part says pipeline failed, then that means that your data has not been loaded. So if you're running just this, this Colab notebook as it is, then it should work fine. Yeah. Then a very easy way to actually look at your data through the pipeline is just to write pipeline.dataset, which I think is pretty cool whenever you're using DLT. So you had declared the pipeline right here to run it, but then you can also use it to actually access your data. We had the Zoom camp _ data named right here in the resource. So that is how you will access it. And as you see, it has all of your data here, and it also has the tag that we added, second 10 days, first 10 days, etc. So that was added with your DLT IDs and etc. Yeah, just to look into it, within these first 1,000 rows, you have 481 rides that were in the first 10 days, 295 in the second 10 days, and 222 in the last one. So now we are done with the DLT part of it. Let's get into Cognney. We'll be using Cognee.add and then Cognee.cognify that Cognify we looked into, and add will answer the question that was asked above, previously, about how you actually add data to Cognney. So here we have a data frame. You cannot add a data frame directly to Cognney. If you have like a relational structure, then there is a way to be able to load that into Cognney. But here I will just be using the simplest way, which is Cognee.add. Cognee.add here, and we add the filtered out set that we want, which is first 10 days, and then we convert that to a JSON, and then add it to Cognney with the node set first 10 days. So this is basically the filter that we want to add when we want to query into it and search into the knowledge base. Then we do Cognee.add whatever data you have, and then the node set. For whoever asked how we add a text document, I think it's just cognee.add, and then you can add like the content here, the string here. I don't remember, but I think there's an option to just add like a file path as well. So you can just, yeah, if this works. Otherwise, they're like adding data into a Cognee knowledge base is as easy as just doing cognee.add. So yeah. So we added the first 10 days, then we filter the second 10 days, we add that, we get the last 10 days, and then we add that with those particular node sets. So now we've added data. We've used the cognee.add function thrice with 3 different filters on our data frame, and we've added it as JSON. And the graph that we'll be creating will be created in this location, and we will look at it, which will be my favorite part. So yeah, then we just run this function, and after this, by the way, is going to take a lot of time, and then we can actually look at the knowledge graph. So I have opened it right here, and this super complicated looking graph, complicated but actually very pretty as well, I think, graph has been created by Cognee, right? So reading this graph, when you run the collab, I would say like take your time and really look into it. So what I would suggest is, first, since we have declared node sets and we called it first 10 days, second 10 days, and last 10 days, so we can look into it, right? First 10, and I think it's right here. We see this right here. We hover over it and we can see, I hope you can see this. It says name, first 10 days, type, node set, and a lot of other stuff, right? If we look for second 10, let me zoom out. Oh, I think I see it. Here's the second 10 days. This is also another node set, but yeah, the third node set will also, node set node will also be found. But as you see, you can see like trip 1, trip 2, trip 3, a lot of this stuff around here that Cognee was able to take from your data and then add here. So it said name trip 12, and it's an entity. The node is called an entity. The second 10 days node is called a node set. Let's see what else it has. Payment type, this looks pretty cool. Payment type, this is a node that says type entity type. And if you want to look into what is inside of it, since it's pretty hard to see right now, what I like to do is just try and isolate it, which is really hard to do, but we see that it is connected to this here, which says string. This node is a string of entity type. This is connected to payment type, which is telling you that the payment type is of string data type, right? What else do we have? This is connected to...
What exactly is a node set here? So this is when we add, can we say that this is a tag for each of the data frames we add?
Yes, absolutely. That is why we added the node sets. It is the tag for those particular data, and the reason that it is, kind of, it's here in all of the different data, the rows that were tagged as second 10 days are all connected here with semantic definitions. So does that make sense?
Yeah, and does it always... So in this case, we just added the JSON, right? So and then it was able to figure out, it was able to parse JSON.
Here, I think we also just, I'm sorry I cut you off, but we converted the JSON here to like a JSON string.
Yeah.
So the input here is text.
Yeah, so then it can potentially be any text, right? And then it
Yes.
tries to parse the text. So in this particular case, it's not important that this is JSON because it uses an LLM under the hood. It knows how to. You have a bunch of text, and then LLM realizes that this is JSON, and this is what it needs to do with the data, right?
Cognee, yeah, reads your data in whatever format it is, and yes, it makes these connections.
Okay, cool.
Yeah.
Thank you.
So yeah, then we can see, I am going to spend like a little bit of time here because it's really hard to read this graph. So it's just here, since we, this is just an HTML file, we can't really query into it. I will get to an example that does that. But yeah, for example, there is this here that says vendor. This is a node called vendor entity type. So vendor is a CMT. Not sure what this is. Okay, this is connected to this red node. This red node is an entire document chunk, which basically here it is telling you that it also, in addition to storing actual semantic definitions, it also stores chunks of the document. And you can see that this is connected to a lot of different nodes here, which can make it easy to look into it. So this CMT node that we have not able to figure out, it contains this. So basically the document chunk contains this. Then you've got trip on this state, which is another entity, a node called trip. And I think this adds all of the other trips to it. Yep, the trip 1, 2, 3, 4, whatever you can see. It has put that into a category or an entity type called trip. And yeah, we are not like using Cypher to query this right now. We will do that in the second demo. But this is just an introduction to what your graph can look like. And I admit that it can be confusing, but the best way is to kind of zoom in, take the nodes apart and see what it looks like, hover over it, look into it and see what the connections are and how they make sense, if they make sense to you. Yeah. Sometimes it can be as easy as saying, okay, string is connected to payment type, so payment type is a string.
Yeah.
But other points.
Sorry.
Yeah.
So I just wanted to add that. So I decided to check how much it actually costs to run this, and I went to platform openai.com, and running this query costed less than 1 cent. So it doesn't show how much exactly; it just shows that less than 1 cent.
Which again, I mean, thank you for bringing that up, because the RAG system that we created, we were actually struggling with the cost quite a lot. This Cognee does by default use GPT-4o Mini, which on its own is quite inexpensive, but still, if you're using like a lot of GPT calls in your RAGs, which eventually you do end up doing, it can be quite expensive. So I think Cognee is also pretty cool when it comes to this. Yeah, we can spend a lot more time on this search, but we don't have that time. So I am going to just move ahead here and say that you can search into it. The search function is just cognee.search, and you can specify the different search types here. There's graph completion, there's RAG completion, I think. There are different search types within Cognee that are mentioned in the docs, but I think my default is usually graph completion or RAG completion. But yeah, to get the best results, you can look into what the different types are. So I just asked Cognee, what's in this knowledge graph? And I gave it the first 10 days. So as we established before, that we have this as a tag. So the search here will be limited to all of the different nodes that say first 10 days or are linked to the node first 10 days. Another thing here is I've limited the search retrieval to 5, which again, it will not look at the entire graph, but there is like a limited search parameter here to look into it. And once we look at the results, it says that the knowledge graph contains a node that represents different trips. And these are a couple of examples: trip 5, trip 6. Those are the nodes that we saw. Trip 6 is related to trip 5, etc. So yeah, you will have to look into the knowledge graph to actually understand what this means or how it's related. I assume that there's like a shared maybe payment type or something, or I mean, they all share the node set node, which is first 10 days. Yeah, first 10 days. So that is also how they're related. So yeah.
I was wondering what kind of questions can we ask? Because I tried asking how many trips use cash as payment method, and it said 3, which is not true, not correct. So apparently this is not the kind of questions, not the kind of question we should ask. So I was wondering if this is not the kind of questions we ask, what do we actually ask?
So this, I added, I would say that the Cognee.add method that I used here is not the most ideal one, because we have a relational data set basically up there in a table format, and I used Cognee.add, which makes a lot of sense when you're adding text. So you know, when you're doing retrieval in that sense, it makes sense to do Cognee.add. But if you use the other method that actually works for loading relational data sets, I think that would make sense to ask the question that you just did. But I think here it would just make sense to ask about relationships. Yeah, for this data set, I would think that it makes sense to ask about relationships. For the other one that I have, it would make sense to be completely wild about the questions that you ask.
Okay, so I guess if it was, let's say, a book, again, Game of Thrones, we could ask, what is the relationship between Jon Snow and Daenerys Targaryen? Right?
Absolutely, yeah.
Okay.
Yeah. Okay, so I'm right. Coming back. Okay, so we have half an hour left, I believe. Yeah, so okay, so this is the second demo, which is introduction to like a real life DLT project that we are doing, and we are actually exploring this solution space with Cognee. So at DLT, it is super important for us to understand API sources, because we build data pipelines, and we were building some RAGs to understand API sources and docs, like actual docs, Poke API, you know, api.com and monday.com/docs, api.slack.com, right? So all of these different source docs, we were looking into it, building RAG structures to understand APIs. Understanding API sources is important to us. And it's important also to us to help you figure out how to write data pipelines in like an AI accelerated way, which obviously understanding sources is a huge part of that. So here are some of, insert Hiba's rant. So this is my rant, that API docs can be huge, and we build pipelines on some predetermined rules, like understanding how the client is set up for an API. We understand how pagination is set up, other auth challenges when you're connecting to a source. So we have those rules, right? And then a lot of different API docs are defined quite differently. So when it comes to like reading docs, there are different, I guess, very silent rules there as well that kind of stop you from understanding every single API source in a very generalized way. And I mentioned this before, but I think it's worth mentioning again that API docs are huge. So yeah, there we use node sets with ontology. Like that is one solution that Cognney provides. So first question, what is ontology? And I really thought the first time that I came across this that we were getting philosophical, but we are not. This is a concept within AI. And ontology is a formal machine readable specification that defines a lot of stuff. It defines entities, classes, relationships, and properties. And we can just kind of look into like some practical examples of how this can work within AI systems, especially. So in any system, ontologies provide a shared vocabulary, which, as I ranted about earlier, there are different ways that APIs can be understood. But there is a very standard way in which DLT writes pipelines or basically automates pipelines. So there needs to be like a shared vocabulary of what it means for there to be a JSON link paginator, for example, or any other offset paginator, or different authentication mechanisms within DLT. So yeah, it provides a shared vocabulary. It does it in a structured way. And once it provides this vocabulary, it can enable reasoning between different systems. So one use case is in business analytics. I think this is like one of the first starter databases that anyone works with when they're learning about data analytics. So you have the different entities, customer, order, product. A customer places an order contains products, etc. But what those things are and how they're related, all of this can actually be defined within an ontology. And just like that, in API docs, an ontology defines different concepts like endpoint, base URL, like book API, I think api.pokemon or pokemon.com/API, something like that. Yeah, whatever the base URL for different sources is, or pagination, authentication, etc. So yeah, ontology helps kind of understand those different things. And it looks something like this. So it is saved in OWL format or in RDF or XML format. And it looks like this. And it is super difficult to understand when at least for me, when I look at it. So I went to our savior ChatGPT and I said, these are the relationships that I have. You know, like I have a resource could be anything, any different endpoint that is offered. And then within that endpoint, there will be a base URL and different parameters to that, like Pokemon/ID. So, you know, these are the different, relationships between different classes and properties that you can define inside of an API docs ontology. So yeah, if ontology makes sense to you, then it's a good time to get into the second demo. So for this one, it is, let me see. Yeah. For this one, the data is hidden because, again, this is like a sneak peek into like one of our internal projects. So the data is hidden. If you want to use the open source part of our session today, then that would be the first demo. But this is just like an introduction to how it can be with, with like different sources. So what we have here is I have these different source locations where I have all of the pages inside the API Slack, the Slack API docs. I have all of the pages of the API for monday.com, for PayPal, and for Ticketmaster. And these are saved as just different files for each different page. I mean, we can look into the examples if we want. Slack API. So yeah, anything that you click on here, all of these different pages that are in here, they're all saved as different markdown files, right? So we have that, and then we have a DLT pipeline where we run all of this data. We get all of the files inside of these different destinations, but then the node set that we're setting here, the tags that we discussed, here are just names of the sources themselves. Why I did this was because when I'm building a knowledge graph and I want to look into all of the endpoints that are in there, it doesn't make sense if I ask it to find all of the endpoints, because it'll give me endpoints from all of these different sources, and that is not of use to me. What would be of use to me is I am building something for Slack. I'm building a Slack pipeline somewhere, and I want to look into all of the endpoints that are inside that documentation. So the node set that will be set here is with the name of the source itself. So when we search into this tag, we will look into just that. Yeah, so we store all of these different API docs inside of a file system. And for those of you who have used DLT, you will know that when you set up a file system, you have to then put a bucket URL here. This is a local bucket, but it can also be somewhere in the cloud. And if it is in the cloud, then you have to just declare here that it is in the cloud. Right. So once again, we're done with the DLT part of it.
Sorry, I didn't miss. I think I missed a part of this. So, can we follow along because the files are missing? How can we actually follow along? Like if we don't have the source locations?
Yeah, this is just to kind of showcase the ontology here.
Yeah, but like how can we follow?
This should be in the repository.
Okay.
Yeah.
Because like it says source location DC drive not human API slide.
Yeah. I think maybe after this ends, I can add like sample pages here.
Okay.
So maybe that'll help. Yeah. So right. So now we're done with like the DLT section of it, and then we go into the Cognee part. And just like we did in like Cognee.add, we have Cognee.add here as well, where, for example, I add all of the sources that are saved with the name api.slack.com. So I add the entire content of, for example, this page that is saved as a markdown file. So I save this and I load it, the entirety of the text, to Cognee using Cognee.add, and I set the node set as api.slack.com. And I also add another node set to it, which is docs, because just in case in the future you want to create a knowledge graph that is larger and you want to add other stuff into it, you can do so. But for now, what I'm adding are docs. So the node set here is labeled docs with the name of the source. Right. And then once again, it is the knowledge graph will be saved somewhere, but this one is going to be hosted at Neo4j, which again, so if you want to use Neo4j, you can do that locally. It's free to use it locally. It is also free for 14 days on the cloud. And then I think the free tier that you have in it, you must load a graph that has less than 400,000 nodes or something, which, yeah, I mean, that's a pretty big number. So you can use it on the cloud if you want. Right. So after connecting it to the cloud and then running cognee.cognify, it creates all of the connections within these API docs, which we'll look at in a moment. And then we have another function here that says cognify with ontology. So the idea that we just went over a while ago for ontology is we just run the same function, cognee.cognify, but we add an ontology path to it. And the path here will just be the spec that I had GPT create. You can see you have like the resource, different API types that are available. This is, I think, for pagination. It's super hard to read this. So yeah, I think there are tools to create ontology files. And then again, you can just ask GPT to make one for you. So yeah. For here, we just ran Cognify with ontology.
I have a question.
Yeah.
Like I am trying to understand what this ontology is for. Like what kind of knowledge do we have there? You said you used ChatGPT to create it.
Yeah.
But in this case, I wonder what was your prompt.
Oh, okay. So I described as I said before. So I have a resource. If I go back here, right, and API docs, we have endpoints, we have base URL, we have pagination, authentication. An endpoint must belong to some resource. An endpoint must have a base URL. It must have pagination. So I just said this in words. I described that myself. And then I told ChatGPT to create an ontology file from it.
Okay.
Yeah.
So basically you copied more or less this thing, added a little more description, and then it generated this whole file.
Yeah.
Cool. Thank you.
Right. And then, yeah, we just run the main function where we added all of our docs. And then we add the Cognify with ontology function with the path to the ontology, which here is saved. And I will also, I think, as Alexei pointed out, I will also add like some parts of these docs. But
it would help, yeah.
Yeah, they're just these pages, for example, but yeah, they're just saved as different files. And I will add a few examples. Right. So
maybe what you can do is you probably have DLT documentation somewhere. Perhaps this could be a good example, right?
Yeah, sure. We can do that. But yeah, I think now for looking into what was created. Right, so this is Neo4j. So far we have been looking at our graphs as these HTML files that are being saved, but now we actually have, we can query into an actual database here, which is Neo4j Aura, which is the cloud part of Neo4j. I just came over, so I'll just show you around a little bit. I have an instance here that I created specifically for this. It's just called instance1, and these are the values that you have to put into your env file, where you have the graph database provider Neo4j. The instance name here, for example, was instance1. So yeah, you just have to fill in that stuff if you use it. And again, for the first 14 days at least, it's free. So yeah, let's just query into it. And I have some particular queries that are saved here because I am not that used to using Cypher. Cypher is the querying language that you use for graph databases. Yes, I am an SQL person, so this is new to me. So this is what we loaded. And as you can see, at this side of the screen, you have the different types of nodes that were loaded. it is limited to 1,000. You have document chunk, you have entity type, node set that you have the ability to like set different colors. So I set this to black so that we can see it. You have text document and text summary. So let's look into where the node sets are. The black one's right here. I assume the one in the center should be docs. Yep, it is. So this node is the docs node set that we created. And this one is developer.monday.com. This is for the Slack docs. And if you don't know where I'm reading here. This one is from Ticketmaster. And this one is for PayPal, right? So once again, this is like super hard to read. So what I'm gonna do here is get this to be a little bit better or clearer. Just a second. Okay. Right. So now we have the node sets here, all 5 of them, and we can zoom into it and see a little bit better of what all of this is. So we see that this is kind of the center node, the docs node set, because it is connected to all of the different nodes. Then we have developer.paypal.com. This is connected to, okay, a node called development team. And the relationship here is it belongs to set PayPal. So I probably saw within the docs that there's something called development team, and it connected that to PayPal. Let's look at Ticketmaster, which is right here. So I think a lot of people might be used to, or maybe have used Ticketmaster. So this is a node called official artist / team creative, which I assume that it pulled out from the documentation as well. I assume that that is some sort of an endpoint. This is impact tracking system. What else is there? There's some sort of a user there as well. Yeah. And Slack. For those of you who use Slack, it's this messaging platform. So it has one node called app. So it saw one concept called app inside of the docs. It saw one other concept called message. It saw one other concept called user, which is super cool because you see that this is one node called user and it's connected to Ticketmaster. It's also connected to slack.com. So you can see that it's building these different relationships within the data. So here I have loaded different text files and it was able to kind of get these different unique relationships from inside of it and understand that there are concepts that exist inside of this data that it can create. So yeah, these it's super cool. I would highly recommend looking into Neo4j if you want to actually understand what your graph visualization has. Otherwise, it's pretty hard to look into something like this. Yeah. So again, using this, we were able to kind of understand a little bit more of what the different isolated topics can be inside of docs. And for the last part, we then can query into it, which I have right here. Okay, so we have the same search function that we had in the other Colab file. the first search command that I've sent here is what API endpoints are in the Ticketmaster API? Give me specific endpoint URLs. And the note set here, which means that I have limited my search to this one tag, which is developer.ticketmaster.com, which means just the Ticketmaster API. And it gave me this answer. So here are some of the, here are some of the API endpoints on Ticketmaster. This is the event search. This is the partner API. This is the ticket management. And yeah, I believe like there isn't any endpoint for this. So yeah, I think that's probably not great, but yeah, I think even these API endpoints, I'm not sure if it's correct, but it gave a gist of it. The event search, the partner API, the different parts that it could find within the API. Maybe the prompt here should be perhaps different if it has to understand what an endpoint is. Then I asked what auth info do I need in the Ticketmaster API, and it said to use the Ticketmaster API, you need authorization, you need the API authorization. So you need nothing more fancy than an API key. What pagination do I need? To implement pagination in Ticketmaster, you typically use parameters as limit and offset. So I think this is pretty cool because this is something that I defined in the ontology. To offset paginator is something inside DLT, JSON link paginator is something else. So there are different pagination mechanisms, and it was able to read which one there was. So I think this is just a repeat. I think what was super cool eventually here was we saw that we had these different node sets. We had the different names, Slack, Ticketmaster, PayPal, etc. But then we also had everything connected to a node set called docs. So when I just ask what sort of API information is in this knowledge graph and the node set is docs instead of something specific, the results here instantly point to monday.com. So it says the monday.com API informs information includes the ability to blah, blah, blah. But that's essentially wrong, right? It is looking inside the graph, but it's not telling me, okay, it has this many APIs inside of it. It was able to find the cluster of nodes that are about monday.com, but not the rest of them. And this is precisely like the point of RAG and retrieval and accuracy, that it looks into, I think, the nearest result, but when the node set was not precise, the filter was not good enough to be able to get to the exact information, right? So it kind of, what do you call it, found like some sort of a local optimal result, which was a particular set of nodes about monday.com. And when I ask the same question for Ticketmaster, it is able to talk particularly about Ticketmaster. So I hope that kind of answered the question about what type of questions you can ask when it comes to search. So, yeah.
And Luca was asking to summarize. So demo one was in demo number one, we didn't specify the ontology. So the graph was, so it just came up with some structure for the graph. Yeah. While in the second case, we specified the ontology, and the ontology describes the graph connections that can be, right?
Yeah, so it doesn't rely on like general knowledge or GPT knowledge. It relies on definitions that you gave that it's relying on. Yeah, so in this case, in the second demo, we say, okay, build a graph that follows the structure, and this is what it did. So it analyzed the documentation that you prepared, and when populating the nodes in the graph, when analyzing the content of these documents, it was actually following the structure of the graph that you defined in ontology, right? Yeah, yep.
Okay. And if we wanted to reproduce this example, the second example,
Mm-hmm.
do you understand correctly? So this is kind of rack on these specific documents
Yeah,
from the API.
API.
And because we follow this ontology, then the retrieval in this case is more focused.
Very much, yes.
Okay, yeah. And in order to reproduce this example, the only thing we need is the files. So we
The
need
files, yeah.
to find something similar. It could be a bunch of documents about some API. I don't know, we use Quadrant, so we can take Quadrant and collect the documentation about the Quadrant API, right? And then use this, and then we will be able to
Yeah,
talk to ask questions about that, right?
yeah, yep, yep.
Cool, thank you.
I mean, I think we have 4 minutes left.
Do we have time for questions, or you want to
Yeah,
show
I
something
think
else?
I made my point while talking
Yeah.
about how Cognee helped just with the ontology, just with the filtering of the node set. So that was the last slide, but I think we can just skip it and go to questions if there are.
Yeah, because there are some questions, and we have been collecting these questions throughout the talk. Some of them I were asking you immediately as we were going along the talk, but some of them I thought it makes sense to cover at the end. So Naren is asking, so you mentioned at the beginning that your role is AI engineer, and the question that he has is how does it different from a data engineer? What is the difference between an AI engineer and a data engineer in this case?
So okay, so you have data pipelines, right? Where you have data being ingested from some source, some data lake or whatever, and then you are moving it to some destination, you are maintaining it. So that is like a data pipeline system. And most certainly there are a lot of different variables that go into maintaining a data pipeline and maintaining data quality within that pipeline. But then when it comes to AI engineer, there are added variables to that as well. Just like, designing this RAG system would not fall into the JD of I would say a data engineer, because there are different things that you need to learn about embeddings. There are different things that you need to learn about the similarity search, or just building a RAG system on its own. Then yeah, just I would say like the AI part of it, and then the pipeline part of it is scaling, right? So as I said, we have a couple of API sources or docs here that I had saved, but in the future we want to grow it, and and when we do that, it then essentially turns into a data engineering problem. So then that is two things in one. So I would say that is where both data engineering and AI stuff kind of combine together for it.
Yeah, a question from Abdirahman. His question is, do you suggest to use DLT to extract a very big data set in Oracle? And big data set in this particular case is billions of records.
Yes, there are ways to like kind of optimize performance within DLT, and you can like find it on the docs. So yeah, I would say like, since I answer like community sometimes, there are people who load quite huge data sets with DLT or move data with DLT.
Does it support Oracle out of the box?
Let me see. I don't remember. Yeah, there it is.
Okay.
Yeah.
Cool. So here you go. Thank you. What else? I think we covered many other things. Just checking if we forgot to. Yeah, I don't see any other questions that we haven't answered yet. Okay. Maybe a question to you. Can you think of a project idea for some of our course participants? Because for us, this is the most difficult part usually at the end when we decide what kind of project to take. Because here, course participants can choose whatever project they want, and because there are so many options, it becomes a difficult choice.
Absolutely.
Do you have some suggestions if people want to use DLT? What kind of project they can implement for this course?
Okay, so we're talking DLT and Cognee or just DLT?
DLT and something else. Could be Cognee, could be, we also use Elasticsearch, we also use Quadrant.
Mm,
I think you
yeah,
support all
so
these things as destinations, right?
yeah, absolutely. I mean, I have used DLT with LanceDB as well. I have also used DLT with VB8 and Quadrant. So you can always go for stuff like that. I think what you can experiment with is the kind of data that you load into it, both in terms of retrieval and generation. When you're talking about embeddings, you can play around with different embeddings. There are some embeddings that are good at reading a certain language. And there are some that are good at reading programming language or generating code and stuff like that. So there are open source embedding models up on Hugging Face that you can kind of experiment with. So you can load different data, different types of data, and make it work with that. Then if you want to go towards perhaps prompt engineering, within RAG systems, I personally think that there are two parts to the prompting. The first part is, the first prompt that you give into it that gets read by GPT or something. And then there's another prompt that you directly put into the vector database to get similar results from. So, you can see what kind of prompts work well with a general LLM like GPT, and then what prompts work well with your own Quadrant or LanceDB retrieval. So yeah, that's on prompts and different data types. And then I think a very kind of an open problem within these systems is evaluation. So I know that Cognee has a part of it that helps with evaluation, but generally in RAG systems, it's hard to generalize evaluation of your results. So that is something that could be interesting to look into.
Mm-hmm. And in terms of particular problems or data sets used, do you have any ideas from the top of your head? We talked about, today we talked about Game of Thrones, we talked about New York Taxi dataset, we talked about API documentation. What else can be the source?
I would say, I mean, even the boring stuff like, the Northwind data set, because um, it's also fun to be able to make your relational data systems or databases work. So you can perhaps just go on to get some data sets on like the coronavirus infections and number of deaths and everything, and you can then analyze that inside of a RAG. Yeah.
Okay, interesting. Thank you. I think that would be all. Thanks a lot, Hiba, for joining us today, for sharing the knowledge about DLT, for showing us how to use Cognee, for doing these two demos. Thanks a lot. It was very interesting for me personally. I've known about DLT for quite some time, but not about Cognee. So for me, this was something quite new. So thanks a lot for joining us today and for teaching us these things.
Thank you for having me. It was really fun.
And thanks everyone for joining us today. So when it comes to the homework, we need a few days. We will make an announcement once the homework is ready. For now, you can continue working on homework too. So yeah, that's all. That's it for now. And thanks everyone, and have a great rest of your day.
Yeah, thank you.
Goodbye.